Ladies and gents, welcome back. We have the fabulous Francesco Nobilia and Richard Noble. They're going to join us from Babylon Health, and they're going to talk to us about a couple of subjects today and their 2-year journey of navigating ways through streaming architecture and just generally their thoughts on data integrity and a couple of other interesting subjects in there. So, like I said, we've got the fabulous guys here joining us. Richard and Francesco, do you want to just give us an intro into the pair of you, or individually, and a little bit about your backgrounds, and yeah, we can kick off.
Hi, I'm Richard Noble. I'm Director of Engineering for Data at Babylon. Been at Babylon for about 3 years now. And one of the first things that I did when I joined was start to work with Francesco on this newfangled streaming project that we're doing on a technology I'd never played with, heard good things about, which was Kafka. And over the last 2 years, we've basically built it out to be very much kind of the backbone of data and asynchronous communications at Babylon. Software engineer, tinker by trade.
Francesco here. Hello, everyone. I have been in Babylon for 3 years now. I'm tech lead for events and data ingestion. When I joined the company, I started at the beginning playing with graphs, and then after a few months, I started working with Richard on the streaming data backbone for Babylon. So background in distributed systems and software engineering.
Nice. So offline, we've obviously had these conversations in regards to joining the business and looking at this 2-year journey of, I guess, transforming data at Babylon Health. Richard, do you want to just give us an intro into what it looked like at Babylon at the start of those 2 years? You know, what you were designing for, what you were hoping to achieve, and of course, naturally, we're going to pick out some problems and challenges in there and uncover those for the audience.
Sure. Much like many companies, many startups, Babylon, when I joined, was still largely a monolith. We had started the migration to microservices, and while I'd love to say we had this vision of all streaming all the time, and we kind of got it solved up front, that's just not the case. Like in so many of these things, we had quite urgent requirements to hit because at that stage we just started, we're planning to operate in different countries. We had split into microservices and we needed to be able to report and bring all the data together in a cohesive way. And as will be, most people will be aware of this, we had this typical thing of you have X months to do this thing. So it was from starting being how do we get this data into a central location? How do we use the technologies that were there? In this case, there were a couple of teams that already started working on Kafka, and getting things out that worked. From there, we started picking up more use cases, seeing the other ways it could help us. And yeah, it's evolved from there.
Francesco, do you want to chip in and talk to us a little bit about working with Richard and what you could foresee would happen with that 2-year journey and what role you were looking to play?
So back then, the role that I was playing was learning. So try to figure it out how as a junior software engineer could work in the organization. But essentially, we had a challenge that it wasn't simple and it was funny. So we learned a lot, and it was a fun journey. So we had to move data from the monolith and make it available for pipelines that were running in Hadoop. There were data transports happening on databases before us, and the idea was, let's try to make it streaming. So we started playing with technology like CDCs or Debezium, Kafka Connect, Kafka streams to try to manipulate this data in a streaming fashion and enriching it and even anonymizing it on the fly. So as as a junior software engineer, it was a constant learning of new things. Although I had a bit of background in Kafka, and I used it before joining Babylon. In Babylon, I started learning how to really deeply using to fit the Babylon use case, and it was a completely different world with what I came across before. So it was a journey of learning and laughing a lot. Obviously, we did mistakes, but that was the best way that we learned
Yeah.
things.
We'll uncover some of those mistakes and learnings in the next 5 minutes. What is streaming data, Francesco, for our audience who maybe haven't played around in this area? What does streaming data actually mean? That might sound dim, but can you try and explain that for us?
So streaming data, I would say it's a type of data. So it's a specific type of data where you have different data sources that are constantly generating new data. And in order to handle this streaming data, this never-ending stream flux of data, you need to apply techniques like streaming processing, where the idea is you don't have the full set to analyze this data. So you have a bit of information, probably other information will come later on, but you need to make a decision based on what you know in the specific point in time. And in order to have these two things working, there are streaming platforms that can help you, that is essentially are ecosystems of tooling and documentation that can enable engineering teams to stream data and applying streaming processing techniques.
Okay. Richard, do you think streaming data is absolutely essential in a business like Babylon or what you set out to do? Do you think it's essential?
I've never worked in a large system, not even in a large company, where there hasn't been a need for some form of asynchronous communication. Streaming data, and specifically eventing, which is the practice of writing packets of data when something has occurred. You'll hear that about a write event log or eventing systems or event-driven systems, and all that is when something has occurred, like an order is placed or payment is taken or anything like that, something that occurs within a system. A record of that is written, and that record is then actionable by any number of consumers listening for that having happened. If you look at it like that, the idea of like eventing becomes really, really valuable in this idea of decoupling different systems from each other and creating anything that scales. Typically, this becomes more and more of a requirement, because what you'll have then, instead of one request having one response, you have one event triggering n actions, and these can stream and cascade, and hence the term streaming.
Nice. Talk to me a little bit about what you failed at, or some failures, or what you learnt along this journey. It's a fascinating journey. Obviously, we're going to uncover it a little bit more, but what did you learn? Or what did you not do so good?
Okay. I think the first thing that I'll say is like when we started on this, we literally embedded ourselves in the streaming pipeline. We'd be reading. I remember telling the team, like, because I realized after a couple of weeks that everyone in the team would get to work like between half an hour and an hour before everyone else, and would leave about an hour after everyone else. And at no point had I asked anyone to do this. And I did. I remember calling everyone together and going, "Guys, you do realize no one has asked you to do this. You absolutely do not have to." So it's this very kind of passionate group getting together, getting to understand all the stuff. That's great. It's really good. It was a fantastic team to work on. But there's one major mistake that we made, which is we kind of thought that because we're doing this, so will everyone else. And we were building a platform that we need everyone else to use. So with our kind of, at that point, quite in-depth knowledge, we were going, yeah, but this stuff's simple. But we hadn't taken the rest of the company and organization with us. So that to me was one of the biggest mistakes we made. Once we realized that, we started doing roadshows, talking to people, pairing with them, trying to get them up to speed to kind of see what we've done there. And to simplify the designs, we kind of solved problems we just didn't have as an organization because we thought this might one day happen. So those for me are a couple of the core ones.
Yeah, we spoke about that inclusivity piece, and the inclusivity, I think, drives so much energy, a forward-thinking goal that people can align with and get on board with. You know, if people feel as if they're part of the journey, you can create something great. You're right. So, Francesco, you're obviously one of those people that were coming to work early and leaving late with Richard. Secretly, I bet he told you to do that. I'm kidding. But Francesco, tell us a little bit about what you learned through the process, whether that's technically or from a people perspective.
So let's start with the people one. That was, I think, the most interesting and unexpected back then. As Richard mentioned before, while building a service, while being in an organization, there is a need. And if you're building something, it's because you're solving a need. And we were solving a need, building a platform. And in the moment that you use the word platform, it means that you're building a tool for other teams. So it means that you need to interact with those teams, with those stakeholders, and trying to have a feedback loop with them to understand how they're using your system, what are the pain points. Because as Richard mentioned, we were spending a lot of time reading about this stuff, watching video, playing with those things, building things, and concepts that for us were bread and butter, for other people were a bit complex because they were focusing on another technical issue. So engaging with the users was really interesting. Sitting next to them to see how they were using our tools also was a very good learning. In terms of tech, we did probably the mistake of building too much. So today, streaming is something that a lot of companies are doing. So there are a lot of different open source tools out there that we could have reused instead of building in-house solution. Advantages for that would be that it's open source, so there are multiple people maintaining it, and there is also online documentation that you can rely on. So it will not be something that you have also to document in-house, but there would be video, there would be conferences, there would be website, blog posts talking about it. The only gotcha on that side would be that you cannot just chain tools and expect them to work like magic. There is still a bit of know-how that you have to put in, even though you're reusing some open source tool to fulfill your business domain.
Nice. Okay. A particular thing that I wanted to focus on that I've heard you guys both use reference to is looking at use cases or looking at users and understanding what you're trying to achieve. And obviously, streaming data is one of those topics. Richard, this is probably one for you. So, how do you define when to stream data and when not to stream data? How can you help someone understand that?
Okay. Obviously, the choice of that is quite nuanced because you can solve a problem in many different ways. But the rule of thumb that I tend to go with is if you need read off the right consistency. So in other words, something like a database transaction where the users entered something in and immediately they need to see the response of that. Well, then maybe the streaming paradigm isn't the best fit for that. You can absolutely do it. You can use a correlation ID to bring the data back. You can use some form of polling. You can use some form of other streaming like WebSockets or server-sent events. But it doesn't lend itself towards that kind of problem. Whereas if you have a situation where an action that has a definitive state or something has happened and you want something else to follow on after that, well, then streaming is absolutely perfect for that. The other thing to keep in mind with streaming is that there is this requirement for kind of ordering. So that you can do this in many different ways, but the one little bit of advice I'd give is, if I may at this point, is whenever you're building a streaming system, make sure you properly understand your order guarantee requirements. If you're only passing little bits of events instead of a fully kind of hydrated domain event, if you'd like to, we can get to that a little bit later. But then ordering is incredibly important. And you will come to issues and restrictions on that unless you've thought through exactly how you're going to handle that particular state. But yeah, read after write or kind of event-driven is typically the two paradigms you'd be looking at for that.
Okay. Have you got anything to add to that, Francesco, at all?
I think that Richard mentioned the concept of ordering, and when talking about streaming data, ordering it may be very complex. And in our case, for example, we put ourselves in the situation where we wanted to have total ordering, and that was a bad call because we didn't need total ordering. What we wanted was that all the events, all the little unit of streaming data that we were spreading around should have been ordered according to the user that was owning that data. So, giving you an example from the medical domain, if I booked an appointment with a GP before or after you, it's not that important. But if I booked an appointment and then I cancelled an appointment, the ordering of these two events, it's quite important. If you have a cancellation before a booking, could be a bit weird, and then you need to handle it somehow downstream. And there are techniques that were not immediate for us to figure it out that you can use to make a very complex problem like ordering a much simpler one.
Okay. So basically, define what you need to do, use the appropriate case. We got it. If you're giving advice or consulting to an individual or a company who wanted to build a large scale streaming platform like you guys have gone and built, okay, what is the advice that you would go and give someone now, or what's the advice that you would give a Richard and Francesco 2 years ago?
I think I would start with saying, make sure you're focusing on the problems that you actually have to solve. The times we've gone off the rails is when we've thought of a smart approach to something and have kind of gone, built it, and then realized there's no real use case for it, or it can be solved much simpler in a different way. Second thing is find some people who know the technology and ask them questions. Trust me, anyone who's in this, like who's playing with these kind of technologies, these are people who really want to be asked questions. They have no problem being bugged about it at all. So anyone out there, feel free. Chances are you'll have my LinkedIn after this. Got any questions? Ask. Go ahead. And thirdly, avoid, and I think I'm going to let Francesco explain why, avoid infinite retention. I'll hand it over.
Please take the mic.
So either you have infinite money, and then you can do infinite retention, or otherwise doing infinite retention on Kafka could be expensive and tricky, especially in our case where we were dealing with medical data, and medical data cannot leave the country where it has been collected. So we have a lot of clusters spread around the world, and all those Kafka clusters are running in production with infinite retention. We have quite a lot of data, and we were doing that because while dealing with events, you want to be able to replay the event log as many times as possible to rebuild a state. But we didn't think about back then that we don't need the data to be in Kafka. As long as we can replay it, it's gonna be fine. But this was one of the biggest mistakes that we did back then. I think we had that slide in another talk that we gave about the infinite retention, saying it's super expensive. nowadays there are solutions like tier storage, or you can offload data with a Kafka connecting S3 and do magic there and make it better, but don't do infinite retention. And if I can add something to what Richard was mentioning before in terms of the basic things that you should have in place when dealing with starting your project, your streaming data project, you must have a solution to handle schema. So we figured out that probably one of the most important component of our streaming platform is the schema registry. And the schema registry is where you keep all the schema representing your data. And if we wanted to compare it with REST API, in a REST API, you have a contract that is explaining to you how to interact with that endpoint. A schema in the context of streaming data is essentially a contract. The contract to interact with a specific topic or streaming channel. And there are so many functionalities, and if you want, we can go in more details, that you can enable if you have a schema. So a schema will not only be a way to define your data, but it will be also a way to annotate your data, or to provide metadata about your data, which can enable automations down the line.
Okay, nice.
The other thing
I like that.
Yeah, the one thing I would add about schema though is the unfortunate part of it. Everyone loves a schema, everyone loves a contract. Unfortunately, these things change, and the streaming system that in and of itself is a bit more complex, because as your schema changes, the older data you may not be able to read, or you may not get the full value of the future data that comes through. So whereas in a RESTful thing, you can just have your version 1, version 2. It's a little bit more complex in a schema, in a streaming system. The little bit of advice I'd give there is Protobuf does a really good job of how Schema Revolution can be handled, but there's some pretty simple rules. The first one is absolutely modify schema by adding a field. Go ahead, but it must be optional. Second one is go ahead, deprecate a field, but continue to keep the data in there until all your clients have been changed to handle the new structure. And the third one is thou shalt not rename nor change the type of any field. If you can do that, then trust me, your life with regards to how you evolve schemas and how you migrate data will be infinitely easier.
Yeah. How tough is it to get that relationship between data integrity and I guess what you're building in terms of this streaming platform and the human element of that? People, users, we've talked about pairing, we've talked about feedback loops. So how important is that to be able to cultivate everyone together to ensure that data integrity?
I think, well, it's incredibly important because honestly, within any kind of data domain, we are only as good as the data we get. What that kind of implies is, and I said this in offline when we were talking about this, is that there is no system without people, and that implies that kind of, at least the way I think about it, any system has people as a component in there, and you need to know how to interact with them, and that is typically how you'll interact using language, because that's the DSL we use to interact with other human beings. And that can be documents, it can be anything else. What I'm getting to with this is the language you use about the data that you're getting and the responsibility that is owned by the people giving the data needs to be really, really clearly defined. The fact is, in my opinion, with any kind of scale up, we have to get to a point where the source of the data ensures that the data that's being sent is of high enough quality that it can be used by people that they don't even know about yet. Because within a streaming platform, you have no idea what your consumers are. Like there might be n different consumers that you never thought about, but because they can go backwards in time and replay things, super valuable. But you're gonna have to guess what you're going to have to try and design something that is as fully featured as it needs to be, that someone else you don't know about it can act on it. The other thing is build observation into everything you do. That's another little piece of advice, which is you can absolutely build the most perfect, pristine system. But if the people that are sending you their data can't see what's happening with their data, well, as far as that's concerned, they've never sent it in the first place, and they have no surety in that.
Okay. Have you got anything to throw in that as well, Francesco, just from what you've seen and building a culture around that?
I think there are also different paradigms that you can use according to the specific streaming use case that you're applying. Like Richard was mentioning, that who is publishing data is then in charge of making sure that the quality of this data is the best as possible. So you don't need to do a lot of gatekeeping at the entrance of your streaming platform to make sure that this data is valid. And this has been a massive, I would say, argument of discussion between me and Richard for years, because we had different opinion. But as long as you have a producer in charge of publishing the data and making sure that they own it, they can provide high quality, that's fine. But something different that we did in the case of CDC, that was one of the very first use cases that we tackled. We provide a simple way to do distinct counts. So in that case, we're just copying data from one database into BigQuery and do a bit of anonymization. And in that case, it was simple to count records and make sure that we had the exact same number given some threshold, obviously, in both systems. While in a full streaming approach where there are microservices publishing data, the best you can do is providing metrics around things to make sure that everyone can monitor what's going on. And probably something that we underestimated at the beginning was the powerful of metadata. You can add some extra information to your records that can be analyzed afterwards in case something went wrong, and you can find out what the problem was. So there are different approaches to make sure that data is valid according to the specific streaming use case that you're tackling.
Okay. If I'm right, you guys have got like an event playbook. Am I right?
Yep. That was something that one of the teams worked on quite a while, to basically work not just internally. This was that whole problem of we're kind of too insular. We haven't been speaking about like to people outside. So we actually put a team together to go and elicit this information from other teams, and we put people on those teams that were not aware of streaming. And so basically, they had very little thing, so they could take it from the very first touch point and document those things that they wish they had known at the beginning. And it's that playbook that's become pretty much the Bible with regards to any of the other things. Anytime you're having a discussion, I've had other engineers say, but in the event playbook, it says XYZ, which is great to read and sometimes proves me wrong. But, so yeah, that for us was a very valuable tool.
Nice.
I think something that we discovered with the event playbook is that our stakeholders were not only engineers, but there were different types of stakeholders. So we had engineers, we had data analysts, we had product people. So something that the team built in the playbook, and I think it was a very good lesson, coming back to your previous question, was making sure that there were different way to explain the same problem with different level of details. In this way, different people with different background could easily digest all this information in our event playbook.
Good, nice. Now we're coming to the end of this 2-year journey. Architecturally, how different do you look from 2 years ago? Is there a big difference? Why is there a big difference? Or why not?
I think the biggest difference that we have compared with the beginning is that we worked hard to remove and deprecate one of the worst decisions that we made back then. That was wrapping Kafka with a REST API. So we essentially built a custom REST layer to publish data into the Kafka cluster and read the data from the Kafka cluster. And this thing was not really loved by the engineers using it. And it was also very hard to maintain. So something that we did was trying to move the entire logic that we put behind those REST APIs into Kafka serializers. So essentially, we completely removed one of the most used services from all the microservices, and helped our stakeholders moving to interact directly with Kafka. So in this way, there was a distributed clusters, which was way more resilient than and available and fast than a REST API. So the full streaming paradigm could have been exploited as much as possible. And it wasn't very complex to make sure that all the functionality offered by the REST API were either converted into native Kafka functionality or the custom business logic put inside Kafka serializers and the serializers.
I think that's absolutely with the tech stack. That's one of the major changes that we've had there. So we're not hiding Kafka anymore. We're giving people access to it via obviously ACLs and all the other bits and pieces that you need. But ideologically, there's also some fundamental differences. We've moved from this idea of, well, if anything happens, you write it with a certain amount of data and very little kind of guidance on that, to this idea of domain-based events. If you're aware of the idea of domain-driven design, and the concept of API thinking, it's this thing of, well, when you're designing an API and you have a domain, when you're doing that, you're not doing it for yourself. You're doing it for whoever's going to come along and look at that, which means you don't want to have a whole lot of jargon in your domain. You want to have this in a clearly defined, fully understandable, and reasonably complete view of that aggregate. Now, when it comes to eventing, we've changed from throw us whatever you got and we've got to put it together later to no, whenever you would think of a significant change to your aggregate within your domain, emit that as an event. Because while your internal events may be valuable to you, and we fully encourage that you do that, what's interesting to anyone else is a significant change that makes sense to them. Once again, an order is placed. They're not really interested in order has moved from one state to another state. They're interested, because that's your internal logic, they're interested in the fundamental, this is done. That then allows us much better control on how we design every component going up from there, as we were talking about the schema earlier. And that then feeds into our kind of data mesh architecture, which is how people would access that, still allowing the core people who wrote the data in the first place to own that full pipeline. So it's this change of give us your data and we'll sort it out, to a we'll partner with you to make sure that your pipeline is pristine and provide you with the visibility of that full process.
Can I ask, what's a data mesh for people listening who maybe haven't done too much around these subjects? What's a data mesh?
Okay. Data mesh in 2 minutes. We are now in a microservice world. Yeah, in general, most I would expect, or at least a service-oriented world. Historically, when it came to any kind of business intelligence data, what would happen is you'd either have a data warehouse, which everyone's heard about, and that is there's one set of gatekeepers. They own all things data. They're the ones that'll make sure everything is absolutely pristine, and they're just going to tell you no. Now, in a microservice world, that doesn't work. We've split responsibility. We've kind of got a DevOps culture. We've got all those wonderful things. The alternative to that is the data lake. Data lake is when anything that is written is stored, and then you build things on top of that. And that's also fine, but trying to build that up into something that is a cohesive whole when you've got maybe 50 different teams all writing their own stuff and all evolving at their own rate, it also really doesn't work. At least it didn't work for us. The data mesh, however, says similar to the way that your operations will be owned by a team that does it, your actual data representation will also be owned by that source team. So it's a mesh because it is how each of those pockets of data are in their own kind of cohesive view. And then the mesh allows us to pull that all together to get one view over the full company and how that's done. So that's in a nutshell. I think
That's a fantastic nutshell. Seriously, that's a fantastic nutshell. Anything to add, Francesco, to that at all?
I think that with the idea of data mesh, you also change how the data team, the kind of work that the data teams are doing. So suddenly the data teams will no longer own data, but they will own guidelines, documentation, tooling to empower other people to handle the data. And this is a completely switch mindset for
Okay.
some data engineers. So essentially, in order to enable the data mesh, there is some very good amount of tooling that you need to have in place alongside documentation to make sure that everything can be bring back together in the moment that you will need it.
Okay. Don't get excited. I am going to ask you guys a little bit about data ops at some point as that comes to fruition. All right. So don't fall off
yeah.
your chairs. Stay with us. What do you think the relationship is between all these subjects get talked about quite a lot? Data science versus data engineering versus software engineering. We see an amalgamation of all these roles, if you like. So, what do you think that relationship is, if there is a relationship there?
I'm going to start this answer off with I have worked as a software engineer and I've worked as a data engineer. I have never worked as a data scientist. To me, data scientists are the data wizards. They take a whole whack of data and they spin fantastic results out of that. My chief aim in this case is either as a software engineer or a data engineer is to get them everything they need and to get out of their way. So big shout out to all our data scientist friends out there. You guys are fantastic. When it comes to like the relationship between a data engineer and a software engineer, to me, these roles are coming closer and closer together. I'm not 100% sure that these are not originally an artificial split. But at the moment, to me, a data engineer is purely a software engineer who has a focus on data tools. There's a slightly different background that you need to do data engineering, but it's still the same problem solving. It's still writing code. It's still making sure stuff is tested. And yeah, I think that's my answer to that.
I think that in the coming years, the difference between software engineers and data engineers, if there is any, will become even smaller than what we are seeing today, because given what we just mentioned about the data mesh, all the experience that a lot of data engineers have to have dealing with data management and data itself will be spread around. So software engineers will get closer to the data engineer kind of specialization, and at the same time, data engineers will be required to build tools to support the data mesh. So data engineers will get closer now to the software engineer. So if today we have some kind of difference between these two macro area, I think that soon they will smash all together, because that's the kind of full set of skills that we will need going forward.
Okay. Well, so where does data ops fit in around here, if it does?
I would say that data ops is very important, and it's a concept that was first mentioned a few years ago, and it's now moving faster, and there are multiple people talking about data ops. But the idea of data ops is like DevOps for data. So it's the lesson that we learn about microservices or building services, and that bring today to the DevOps culture. The same stuff, the same kind of thinking happen with the data domain. So data ops is focusing on making sure that the data pipelines that you're running can be easily replicated, or making sure that there is a specific and very good monitoring and alerting around your pipeline. So there is a very good actually a data ops manifesto listing way more items than what I just mentioned. I think there are either 12 or 15 different items. I do suggest to take a look, because the brief description that I just gave to you is
It's
not.
good.
It's good, but could be better.
Have you guys introduced it?
We have a like Jeremy, who's also one of the first people that worked on this, has been with us the whole way. And he has a data op, like he runs data ops for that. We are embedding data ops engineers in a bunch of the data teams, so that we don't end up with kind of the DevOps team or the data ops team, but people that work within there and have the skill sets to do these jobs and perform these roles.
Nice. Okay. What sort of skill sets would you think you would look for if you're looking for these people?
Data ops folk, or just engineers of all stripes? Because I would put, once again, like data ops folk, they're engineers too. They're just on a different level. For me, it's always more important to have someone who has the curiosity and, see my language, but the balls to try something, to go out, to try, to fail, then to figure out what went wrong so they can do better next time. It's a person who will sit and argue with me, be opinionated, but either of us can be wrong, provided we're willing to kind of put our egos aside and go, what we try and do is solve this problem. I mean, Francesco mentioned the many arguments we've had. I would say they're debates. He will call them arguments. That's fine. But because we're always trying to solve the problem, that's fine. It's a case of, and someone who's going to enjoy what they do. Like, there's no reason to be doing this job unless you thoroughly enjoy solving problems. Those are big things for me.
What do you look for in a teammate, a hire, Francesco? This will help the audience, because I think now I've had a couple of these conversations. A lot of people are looking for curiosity. I think quite naturally, because you want someone independently to go and try and solve something themselves, or look for answers themselves, build up an argument to that to approach the problem. But what else do you think you might look for when you're looking for people, Francesco?
I think that when building a team, one of the most important soft skill that we always look at is having a very good team player. So if you're part of a team, you need to collaborate with other people, and we encourage all the guys to make sure that they can easily share knowledge each other, and they can even coach each other. So often you don't need someone senior than you to coach you on something. If you're sharing knowledge, if you have those debates, as Richard was mentioning before, you can spend time, for example, at the whiteboard, and explain complex problem in different words, and suddenly you can help the team while helping yourself as well. So team player is definitely one of the most important things. I know it's very common, everyone is looking for team players, but I really value it.
Good. I love that.
There's
Lastly,
another
before we
thing.
wrap up,
I'll add. Sorry, I'll add
yeah,
one more thing to
yeah,
that,
jump in.
and then I'll let you go. Someone who thinks of more than one solution.
Okay.
I want someone, when I'm talking to someone about a thing, I want to know that they've thought about 3 or 4 different solutions. Probably at least 1 or 2 of them really bad, but that solves the problem, because it shows an ability to think out of the box. What I've seen quite often in engineers is they've got a solution, that's the solution they're going with. And they won't necessarily look outside of that because they've kind of gotten tunnel vision. Someone who can pull back, look at things from an oversight perspective on the project they're working on and go, actually, it'll save us more time. There's a better way. There's a thing, is gold dust.
Okay, nice. I like that. And lastly, what's next for data? If you're able to maybe summarize some thoughts, what you see, and we've spoken about data ops. Thanks, Jeremy, for introducing that. But what do you think might come soon for data?
We've done a bit of discussion about data meshes. I think they're going to become more popular. Something that we haven't discussed offline, but and I'm not going to talk about a lot here. I'm hopefully going to write an article about it quite soon. Is the idea of data governance as code. We have infrastructure as code. It's a thing. We have GitOps. We've got all those kind of things. But data governance is one that seems to have fallen a bit behind. So it's something we're busy working on. Not going to go into much detail about that, but where we can define as kind of rule sets that will be pushed and have that very, very kind of documented, iterative approach to how we perform data governance, but in a way that is as lightweight as we can possibly make it.
Okay. Francesco, your thoughts?
So I think data mesh will come, but probably it will still need a bit of time. What I really expect to explode soon will be data ops.
Okay.
Because I think that we are reaching the maturity of that mindset, that particular area. And something that I'm closely looking into is way to document your streaming solution. So in the same way that we have stuff like OpenAPI or Swagger for REST API, what do we have for events? What do we have for our streaming services? And there is an open source project called Async API, where those guys are looking into how you can document your streaming services and make sure that you can advertise what's happening in there. And they were mentioning together with the data mesh in the InfoQ trends for 2020. So I think that these two aspects will be very surprising in the coming, hopefully, months, if not years.
Nice. Okay. Lastly, I always do this for companies. Are you guys hiring? Richard, what are you looking for? Do you want to just give us a really quick snapshot before we wrap up for everyone?
I think we're always looking for good people. I think that's the stock answer for anyone. We're looking for really smart engineers that are looking to solve problems, tackle big things, work fast, all the standard things. But personally, I'm looking for problem solvers, creative thinkers, people that are going to be passionate about what they do. And yeah, if anyone's interested, feel free to hit me up. Check out the website. There's a bunch of positions there. You know if this stuff works.
Hit up Richard, everyone, for data governance and his blog post coming soon. Follow him. Reach out to him on careers. Check out what Francesco's doing in regards to similar things around Async API. Follow us, like us, share us. Reach out to me, pester me even. If you want to come and share some stories. Guys, massive thank you. Superb articulation on what you've done. Phenomenal journey. Thank you so much. Thank you.
Thank you for hosting us.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no_. We've also got a website which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.